Hello, this is an introduction to the Unicore GNSS board, an all-constellation multi-frequency solution designed for high-precision positioning. This is the UB9A0 board, which is designed for surveying and mapping applications, capable of supporting a wide range of scenarios, including cores, portable base stations, seismic monitoring, and global monitoring stations. As a next-generation product, the board offers multiple enhanced capabilities, such as multipath mitigation, jamming detection, anti-jamming, independent tracking of different frequencies, and delivering up to 50 Hz raw measurement data and positioning outputs. UB9A0 maintains the same size and interfaces as the previous generation, and remains compatible with the mainstream OEM boards on the market, making drop-in replacement seamless and hassle-free. In addition to the standard data interfaces, this board features an external clock interface that supports adaptive use of either internal oscillator or external 10 MHz or 20 MHz clock for time synchronization. Its network interface supports both 10 megabits and 100 megabits bandwidth, ensuring smooth data output at 50 Hz and reliable differential data transmission. Notably, a PBS interface allows time alignment with GPS or BDS system time, achieving RMS accuracy of within 5 nanoseconds. Compared to the previous generation, UB9A0 supports an expanded list of frequencies or constellations, including the B2B band of BDS, G3 of GLONASS, E6 of Galileo, NavIC system, as well as SBAS, the satellite-based augmentation system. Here we can see the frequency map covered by UB9A0, which includes all the mainstream GNSS systems and frequencies. It also supports tracking L-band signals, enabling precise point position service for our customers. Currently, the board supports open SBAS correction services such as B2B and E6 high accuracy service, achieving convergence accuracy up to 15 centimeters within 15 minutes. Built on chipset Nebulous 4, UB9A0 features a dual-core CPU, supports 1,408 channels, and integrates RF, baseband, and application, being able to independently perform high-precision baseband processing and RTK positioning. Compared to the previous generation, it offers enhanced computing power and performance, enabling expansion of frequency map in the future. Another highlight is the remarkable reduction in power consumption. For the previous generation, the power consumption was 2,800 milliwatts, but UB9A0 has made it 800 milliwatts, which extends the battery life of portable base stations. UB9A0 has made significant improvements in jamming detection and anti-jamming capabilities compared to the previous generation. It can detect interference in the environment and provide real-time outputs of jamming intensity. Typically, base station sighting requires recording 24-hour data for post-processing to determine whether the location is suitable. Continuous wave jamming and narrowband jamming are two key performance metrics. The table displays the test results for both types of jamming. The board achieves a jamming-to-signal ratio of 75 dB and resists CW jamming up to 80 dB, improving the efficiency of base station sighting while reducing the difficulty and cost. Even in the presence of certain levels of interference, the board maintains excellent anti-jamming capabilities and can score the environments for station sighting suitability, lowering the overall deployment cost. The observation data quality of the UB9A0 has also improved significantly. On the left, the TEQC results, measured in an open environment, show a data utilization rate as high as 99.9%, exceeding the industry standard of 97% to 98%. The cycle sleep ratio reaches 30,000, well above the industry standard of 10,000 to 8,000. On the right, the zero baseline noise specifications for the UB9A0 are displayed. The pseudo range is within 10 centimeters and the carrier phase within 1 millimeter, both fully meeting industrial standards. This slide shows a summary of the technical specifications for UB9A0. Looking at some of the key parameters, we can see it supports all constellations at high positioning accuracy. When external power is connected to V backup port, the initialization time, also known as hot start, is condensed within 5 seconds and has a reliability of 99.9%. Additionally, it takes only 12 seconds to cold start. More info is given in the user manual. Just click and find out. Now the question is, how do our customers in base station field benefit from UB9A0? In this regard, UB9A0 stands out in the following aspects. As the third generation, the board inherits the application areas of its predecessors, such as base station applications, global tracking stations, and coarse networks, and furtherly extends to atmospheric and seismic monitoring scenarios. The board is developed based over 15 years of experience accumulated through a wide range of base station construction projects, both domestically and internationally. Stability is another highlight. UB9A0 can achieve over 200,000 hours of fault-free continuous operation, equivalent to approximately 22 years of uninterrupted performance. This greatly exceeds the industry standard of 200 hours. UB9A0 is designed to withstand temperatures ranging from -40 degrees Celsius to 85 degrees Celsius, and relative humidity of up to 95%, allowing it to function resiliently even in extreme environments. Seismic and atmospheric monitoring applications require the receiver to support a data output frequency of at least 50 Hz and demand lower data latency. In this regard, UB9A0 performs exceptionally well. On the left, you can see the 24-hour data continuity at 50 Hz through network transmission with zero data loss. On the right is the latency data from baseband processing to data outputs. The average latency is 14 milliseconds, with the maximum of no more than 20 milliseconds, providing the foundation for supporting 50 Hz outputs. This represents the most significant improvement compared with the previous generation. Now let's talk about the supporting tools for UB9A0. On the left side is the EVK 5.0, which is designed for Unicore high-precision board products. You can directly mount the board to the pin socket, on which there are also power, RF cable, serial, and network ports to enable the communication between the host computer and the board. After that, you can configure the board according to the protocol manual to retrieve the relevant data. On the right is an evaluation kit sold by Unicore, UniKit, which supports 4G communication. In addition to the hardware tools, we also offer supporting evaluation software, UPrecise. UPrecise features a graphical interface that allows you to easily monitor the product's performance, such as constellation view, satellite frequencies, signal strength, and geolocation information. Unicore partners with two fully qualified OEM factories and operates 5 advanced production lines. With a comprehensive quality assurance system in place, Unicore ensures consistent production of 10,000 pieces per month with guaranteed quality. This concludes the basic information about UB9A0. If you are interested in this product or any other Unicore offerings, we'd be happy to hear from you.